Hey everyone, my name is Adam from IBM, and I'm joined by Kate, our Director of Technical Product Management for Granite, as well as Gabe, our Chief Architect of Granite for Developers. So we recently launched Granite 3.3, and when we launched that, we thought on the day of launch it'd be helpful to, just do an informal Q&A session on our Reddit thread that posted about it. And, we've really loved the engagement, on that launch thread. What was really cool was seeing some of the comments and delighted or surprised that IBM was jumping into Reddit thread and answering AI and Granite questions. And, we understand that just given how fast things move, we want to move fast on getting AI devs what they needed, what their questions and, comments. We're always trying to lower the barriers of access to AI expertise. And so that's why I'm joined by these two. From that thread, we wanted to dive deeper into some of the common topics and questions that we, found. But before we dive into things, I'll kick it over to Gabe, just kind of talk a little bit about how IBM engages with developers a little bit.
Yeah. Thanks, Adam. And this whole world of bringing large language models to developers is pretty new, frankly, at IBM, and it's really exciting to be involved in it. We, have earned a reputation as a big company that maybe often moves behind the scenes, but frankly, we're also made up of developers that love tools that just work. And for me personally, when I saw the very first Granite models that I could get into my hands and run on my laptop, it just changed the game completely for me for AI. And it's just really exciting to be able to bring that directly to folks out there in the development community. So, we believe that with these small models and the developer needs to actually build things that help them and work. Having models that they can grab and get a hold of is critical. That they can then use and iterate on and build on top of is critical. And at IBM, we have a whole lot of different balls moving with different product lines. And the key with these models is that they can be at the heart of so many things. They can be at the heart of public experimentation done by folks on the internet. They can be at the heart of some of our biggest product offerings. It's the same models powering them, and it's all about what you can build with them. And so we don't believe that we need to keep these models for ourselves. We think this is something that just helps everyone move the ball forward on
AI. Cool. Yeah. So Kate, Kate and Gabe, I know we gathered some of those, try to categorize, a lot of the common questions and comments. Kate, I think you'll help kind of lead the conversation a little bit of diving more into those topics. So yeah, we can kick it over to you.
Yeah, thanks so much, Adam. So maybe just a quick step back at what we actually released, because we're really excited to have brought Granite 3.3 out yesterday. There's, I'll say 3.5 things that we released. So first, of course, is an update to the language models. 3.3, we've released new base models and instruction tune versions of our 2B and 8B models. And those models demonstrate, improved performance on math-based reasoning tasks was kind of our main focus. We also added some additional support in the base models for FIM, identifying, the needs to be able to drive more FIM use cases. And we complemented that release with an update to our speech model. So we actually released our speech model kind of in stealth a week ago on top of 3.2. We followed it with a release of the speech model updated on top of our Granite 3.3 language model. So that's now available. And we released a series of LoRA adapters. Those LoRA adapters are designed to help folks use Granite in different RAG use cases. And we can get a little bit more into that because I know we had some questions on the thread. I said 3.5 because there's actually one more component that we released that people might not be fully aware of. We released a new type of LoRA adapter. We actually published a white paper. There's a blog that went live today on something called an activated LoRA, which is a new innovation that we've been working on that's going to play very well with some of these concepts for LoRA adapters to help tasks like RAG. So everything that we released in a LoRA adapter form, we actually also are working to release in an activated LoRA adapter form. Most of them are already posted online and more are going to drop in the next couple of weeks in order to help folks run these workflows more efficiently at the end of the day. So Gabe, we got a lot of great questions from the community. It might be nice just to kind of talk through some of the topics a little bit and work through some of these high level questions that the community had, because there's a lot of great information. Yeah. First, there was quite a number of comments on GGUF. Can you first tell us a little bit more? What is GGUF? And then what did we do with Granite with this most recent launch?
Absolutely. Yeah. It was really cool to see all of the reactions around GGUF. And I guess it's not terribly surprising given that we did this on the local LoRA subreddit. So LocalLLaMa is a subreddit devoted to folks that want to run models locally. And there is a really strong set of tools out there in open source for doing that, largely centering around a tool called llama.cpp. And under the hood behind that is a framework called GGML. You'll notice the GG is familiar here. And I can say with 95% certainty that it stands for Georgy Gurganov, the mastermind behind some of these awesome projects.
What about Gabe Goodheart?
I know, maybe one day we'll get some hallucinations to fill it in with Gabe Goodheart. We'll see. But the GGML is the Georgy Gurganov GGML ML language, modeling language. GGUF is the unified format. And the real value of the GGUF format is that it packs everything into a single binary blob, and it's backed by a set of runtimes that can open that blob up and execute it very, very quickly. So it makes for extreme portability. You don't need to worry about grabbing a whole pile of different files and making sure you have the right version of a Python library to load it. It's just one big binary blob. It moves around very easily. And the other piece is that the actual runtime behind it, powered by GGML and Llama CPP, and in the case of OLLaMA, their novel tensor architecture that they're working on, it loads really fast. So sometimes you have these huge binary blobs that take minutes to open up, but you can actually boot up and run a multi-gigabyte GGUF file in a few seconds, if that. And so I think there's just a huge appetite for this from just an accessibility. On the Granite for Developers side, one of the things we really focus on is 5 minutes to fun. And every little piece of complexity we can take out of the picture is a huge barrier reduced to somebody being able to get up and running. And so the GGUF format is perfect for that.
Awesome. So a couple of questions on GGUF specifically. Is it a custom architecture? This is referring to Granite, or can it be converted to GGUF? What about the speech models?
So those are both great questions and ones that I'm intimately familiar with. So the Granite 3.0 models or 3.x models that we've been iterating on here, this is 3.3, are themselves a custom architecture that I worked hard to get into the Llama CPP platform and the OLLaMA platform. So yes, they can be converted to GGUFs, and no, for the the Granite 3.3 release, we did not change the architecture. And that's actually a really interesting point, that when we change the architecture, it actually requires deep code changes that have to roll out into those key runtime engine repositories. So the speech model is a different question, because yes, that one is a custom different architecture. We could probably unbox a little bit what's in that speech architecture. It's actually a really cool way that the team approached it. But fundamentally, it's actually multiple different model pieces all coming together in an orchestrated way to act as a multimodal model. It's got the language model under the hood. It's got an actual encoder for the audio portion of the input. And then it's got a special LoRA adapter that's baked along with the model that you tack on the side that allows the language model to consume those additional speech tokens. So the combination of that is actually a whole bunch of software engineering to get that to work. And I commend Alex Brooks on our team for his diligence in making that work, even in Transformers and VLLM. We haven't yet gotten to making it work in any of the GGML ecosystems, but that's certainly something that's on the to-do list. So, the speech modality is a little bit less mature at the end user running it locally game. There's the Whisper CPP tool that's based also on GGML. So that's an interesting target we're going to look at. But right now, there isn't a runtime engine for the speech model in GGUF. So we don't actually have that implemented and ready to go, but we're certainly looking at it.
Great, thanks. And you mentioned a couple of different runtime engines and different partners that we work with basically to get Granite up and running. I'm wondering if you can maybe just share a little bit about the work that you do to make Granite and those custom architectures available, and where you can get Granite today thanks to that hard work.
Yeah, no. So that's a great question. There are a whole bunch of LLM runtimes out there in the world. A lot of folks are going to be familiar with transformers as the place that pretty much all of this stuff starts. Hugging Face transformers is where these models sort of first come into a standardized format. And that's a fantastic place if you're wanting to iterate, if you're working in a Python ecosystem. If you're working in a hosted system, VLLM is a fantastic engine out there that's really optimized for throughput. And it's something that our platform team works deeply on for our larger model hosting. So those are the two big platforms we start with always. But beyond that, to get things into the hands of developers, we really focus on a whole collection of tools that are meant to run locally or in sort of commodity spaces. So Llama CPP is really the root of a lot of that. LLaMa is one of our partners that we work diligently with. We really love how they've mastered the 5 minutes to fun. It's just so easy and simple to get up and running with models on LLaMa. And they also have some really nice syntactic sugar around multi-model ecosystems where you've got 2 or 3 different models that you want to run with, but maybe your system can't handle running them all at the same time. It just seamlessly swaps between them. It seamlessly shares resources. So there's some excellent work done there. LM Studio is another excellent tool that we partner with. They also have their own runtimes that they've got custom optimizations into, and they've got a really fantastic UI built on top of it for tinkering and playing around with the models and chatting with them. There are other additional ones. We've integrated with LlamaFile, which takes the single binary form even further and says, we're going to actually bake the runtime directly into the binary too. So you can literally grab this multi-gigabyte binary, chmod plus X, and then run the darn thing, and you've got a server that runs your model or chat with it. So that's another one. We've worked on conversions to Onyx formats, which work for our dense models, and that works with the Onyx runtime, which is actually really popular in a lot of embedded spaces. We have early work with the Torch Chat team to work on embedding in their ExecuTorch ecosystem. So there's a whole slew of these different model architectures, and the work to make any of these work is essentially to take the architectural deltas that we have on top of other well-known models like Llama and re-implement those in these different contexts with these different frameworks. So it's a whole bunch of work, but it's a really fun collection of tasks that we've been dug into for the past 6 months, 9 months, however long it's been since we really bootstrapped this thing.
Awesome. It's really cool. And it's just really exciting to see all the work that you guys are doing to help get these models out, just broadly in the open source, right? Speaking to some of your comments earlier. Let's change topics a little bit. LoRA adapters, I mentioned, was a big part of the release. We saw quite a few comments on the thread on LoRA adapters specifically. And I know you've worked closely with the team on not just getting the LoRA adapters out, but like how can you run them and orchestrate them at inference time?
Yeah.
So maybe you can start and just share a little bit about how we're thinking about the LoRA adapters and the Granite IO project that you've worked on.
Awesome. So first, let's just take a brief step back for those not familiar with the concept of a LoRA adapter, just a brief description of it. So a LoRA adapter is, you can loosely think of it as like an augmentation to the model weights and the tensors that are going to get multiplied, and the tensor math that's going to go on to actually produce your outputs. So a model itself is a whole pile of different matrices that all get combined together and jammed together and pulled apart in different ways with different operations that are all implemented to work on your hardware. An adapter essentially augments some of those operations with additional weights that have been tuned to allow for additional capabilities. So you can think of it as like a bolt-on that goes on the side of your model and lets it do extra stuff. Actually, Kate, coming out of your team, has been some really amazing vision around how we can add new capabilities to the family of Granite. And looking at it conceptually, right? We sit in research for a reason. So we're not just focused on Granite, we're focused on the technology that allows us to do this. And really, there's 2 ways to bake new capabilities into a model. You can either, I'm a software engineer, so I love this analogy, statically link them, which is to bake them in at tuning time for the core model, or dynamically link them, which is to build a LoRA adapter that you can then bolt on the side. And so if you actually, unbox the chat template for Granite starting, I think, in 3.1, but definitely in 3.2, we actually have a whole bunch of these intrinsics, these special capabilities baked right into the model. The models themselves can produce citations against a set of documents you give them. They can produce hallucination evaluations. But we can even do better with that if we have dedicated LoRa adapters to do the task really, really well. And that's what we released this time around. So we basically have, we're dipping in both strategies here. We've got the static linking for some out-of-the-box capabilities, and we've got these dynamic LoRas that you can bolt on. And Kate, you mentioned the activated LoRa at the top, which is a super cool piece of tech that, like, I'm only the messenger here. We need the real experts on here to talk about it in depth. But the really cool part about this is, for those of you that have ever like looked under the hood of a transformers architecture, it's actually not one call to a model. It's actually many calls in a loop to the same model. And the nice thing is, it's deterministic when you make that call. It's just a bunch of matrix math. There's some non-determinism at the sampling on the output. This is if anyone's ever played with the temperature value or the Ks or the top Ps or all of the sampling parameters. But if you're going to run the same sequence of events, you're going to get the same outputs. And that's typically handled in these runtime engines with what's called the KV cache. And that thing allows you to zoom ahead and not have to recompute all the previous values when you want to tack one more token onto the end. And typically, the way a LoRa adapter works, as I mentioned, is that it basically goes on the side of the model. And what that would do in this context is it would invalidate every one of those previous tokens in your cache, and you'd have to start over at the beginning. But activated LoRa is essentially a way of tuning the LoRa such that it can actually work to just bolt it on at the end and generate one more token with the KV cache that you had before. And frankly, that's still magic to me. I haven't read the paper. I don't know how they do it, but it's amazing and it actually works. And so the really cool thing that this allows us to do is at the composition time, we can start not just having a model plus one adapter that's our end-to-end flow, but now you can think about, non-linear flows of models and adapters, where first you run the model through with all of your context documents with no adapters. Then you bolt on the citation adapter and do a pass to the citation adapter. And in parallel, you bolt on the uncertainty quantification one, and you can now get, hallucination evaluations and citations generated in parallel without having to redo your KV cache. So it's this really cool technology that we're just starting to unbox. Now, the tricky thing about this is, I use the word orchestration, right? It's all how do you cobble it together? And that's a software engineering problem, which is great because we all love software engineering, but it also means someone's got to put that software that's engineered somewhere, right? And there's a tricky question of whether that should live on the server side behind the runtime engine, or whether that should live on the client side in whatever code is going to call the model. And we know that this is a multi-model world. Like, we love Granite, but Granite is not the only game in town by a long shot. And so we know that asking developers to commit to using Granite and using very Granite-specific things is a big ask, right? People are going to pick up different models. They're going to tinker. They're going to play. The Granite IO project is our attempt to solve these problems on the client side and do it with as light a touch as possible so that it can pass right through to other models that aren't Granite, but it allows people to actually take advantage of all of these awesome things that Granite has to offer. So that's how we're trying to thread that needle.
That's awesome, Gabe, and a really, really good overview. Thank you. And maybe just to also share a little bit of our vision on the why and like why we care about this. I think from our team's perspective, and I'm so glad you called out, Gabe, that we're working from IBM Research. We're actually not part of a product team in the traditional sense. Everyone who's really behind the Granite effort, all our researchers, doing this to try and advance the general field, as well as produce useful tools. And where we see a lot of exciting innovations happening is at inference time. This is not new. Everyone's seeing this. There's tons going on from reasoning, from inference scaling, and other capabilities. And by bringing in more modular approaches and working on LoRAs that you can quickly swap in and out while reusing KV caches to do these nonlinear flows like Gabe described, we think there's going to be a lot of opportunities specifically for small models to run more inferences to enrich the response of the small model and produce a much richer, more valuable result without having to have all of the compute overhead or investment behind running a much larger model. And so it kind of fits really nicely to our strategy of focusing on small, focusing on locally favorable models, and then having all of these kind of modules so you can swap in and out at inference time. Maybe we're running more inferences, but we're able to create a much richer result and output. And so this family of RAG LoRa adapters really is kind of our first set of LoRas that we're releasing specifically for the RAG domain in order to start to test that hypothesis. And that's why they're all released in an area of our Hugging Face space called Granite Experiments, because ultimately this is an experiment. We really want people to try it out, get feedback, see how they like it. And using the Granite IO library, hopefully we can provide some really nice orchestration so that we can do some of the heavy lifting, so that you can more easily apply those LoRa adapters. So definitely recommend checking it out if you haven't already.
Yeah,
and you'll hear more and more with the A-LoRas too.
There was a comment there about whether folks can pick these things up and use them in their research. And like, we would love that. Please do. And please tell us how your research goes, because we want to find something that works for folks. If it goes great, we want to know that we're on the right track. If it doesn't go great, we would love that feedback too, to help understand, whether it's a technology problem, an implementation problem, or what. But this is a fun collaborative space, and we want all the feedback we can get.
Yeah,
Absolutely.
So something that we're trying to do is even just DM folks on Reddit who post cool projects, or on GitHub if they post socials, like, hey, what are you doing? And I think something that we're working on is trying to feature, have IBM kind of feature some of those developer stories, I think is the term we're kind of using, right now. So yeah, more to come on featuring some of the, on that. But yeah, as Gabe said, definitely we want to hear more from developers on that. So if you see a DMM from us, on Reddit, please answer, and we're gonna love to chat more, through that.
That's awesome. So maybe just moving on, there were some questions about Granite 4 that I thought might be helpful to maybe paint a little bit of a vision picture of why we're doing this, what's coming up next. So, I already talked about a little bit our strategy on small and local. That's not going to change with Granite 4. And Gabe, you put it really well. We at IBM have invested in a multi-model strategy. Our products have Granite. We have partnerships with Meta, with Llama models, with Mistral, and we really believe in open AI, but having mixtures of different models, different tools for the task at hand. And where Granite's really trying to focus is providing some nice opportunities on the small model side that can be used in, potentially in tandem with larger models in order to help drive tasks more efficiently, kick the tires locally more easily, better tools for developers to experiment and build with, and ultimately create just a richer ecosystem. So our focus on small is not going to go away with Granite 4. We're going to potentially get a little bit bigger. We saw some comments about, getting a little bit larger from a model size between 14 and 32 billion. That's a pretty good bet of where we're probably going to be headed soon. So stay tuned. While still trying to make sure, these models can run nicely on a, relatively lower grade GPU, or locally, when they're quantized down. So expect more there. What we are also really focused on, building on some of the work and the strategy that I mentioned on LoRa adapters, is making these more inference efficient. So obviously the models that we just released were dense models. We have some really nice MOE models that are even smaller. You can expect to see some more work coming out on the MOE side with Granite 4, and some additional work that we're doing to try and continue to focus on how do we run small models more efficiently, running them more time at inference in order to drive better performance. And we think there's a lot of really fun runway ultimately ahead that we want to embark on it and work with the open source community on behind it. So, maybe just to close, Gabe, wondering if you can share in, just kind of a few words, why are you excited about IBM working specifically in the open source? You spoke a little bit about this at the beginning, but what opportunity do you see for IBM to really get right here when it comes to open source in Granite?
Yeah, I mean, I think that IBM has a really remarkably unique opportunity in open source, actually, compared to a lot of other players in the landscape. IBM is a huge company. We've been around for a very long time, and we have a lot of different revenue streams. every single product that we build uses open source somewhere. We are deeply familiar with the value of open source. We've been contributing to it and part of it for decades, if not our entire. Well, I guess open source probably wasn't around when IBM was founded, but open source is in the bones of IBM, and we've gone back and forth at different times in our history about how much we contribute to open source versus how much we consume from open source. And in this current era of AI, for us, the writing is on the wall that the innovation is happening in the open. And, yes, there is innovation happening behind closed walls, but fundamentally, this is like the closest that cutting edge science and consumer facing capabilities have been that I've ever seen in this world of software engineering and computer science. So having these cutting edge research things happen in the open is critical to getting those capabilities into the hands of users very, very quickly. And here at IBM, we believe in the models being open. We also believe in the capabilities being open. And we believe that having those things in the open will build a community around the tools and the models and ultimately be beneficial for us. We're not purely altruistic here. We believe that we actually have some great products to build by putting all of these pieces together. There was an announcement last month of the donation of 3 key software components to the Linux Foundation, Dockling, BAI, and Data Prep Kit. These are all key pieces in the software stack to get the most value out of this moment of AI. And this is just kind of the ethos that we're embodying here at IBM. So I'm really excited to work on it because I love open source. I've been working in open source since long before I was at IBM, and it's where I'm passionate about sharing software with the world and with inspired colleagues that I've never met before. I think it's great for IBM strategy. It's also just really fun to work on, and it feels great to be part of this community.
Awesome. Adam, anything from your side?
Yeah, I think the big thing, I think I mentioned this at the beginning, but just kind of lowering those barriers of access, to experts like you both, but also I think we have several thousand, folks I think have your research. So I think it's just I think just getting the information developers need, the content. I mean, we're gonna post this to Reddit, and LocalLLaMa, and just say, hey, what else do you want to hear about? And so I think just getting that dialogue going with the community, I think is something that is very top of mind, for me.
All right. Well, thanks. This was really fun.
Thanks, guys.
Yeah. Well, thank you. Yeah. We'll close things out, and hopefully we get a vote on that post or two. No, I think you can only do one at a time. But yeah, thanks, folks. And thank you, Kate and Gabe, for helping out, jumping on.
Awesome.
All right. Take it easy.